Good morning. How are you this morning? Good to see you. Not sure where the students are. I guess they assume I'm not hosting a lecture today. But at any rate, they can watch it later. Buenos dias. Maybe some students will come in. So, how was the test? It looked good on my side. I got some good papers. I was pleased. So, how was the test? As I said, it looked pretty good. I need to mark it. I need to mark it this weekend. So you'll have your results by the end of the weekend. No comments? I think you did good, so you should let me know. You did well. You did well. You did well. I'm going to have a look here. So, I'm just checking something. Can you hear me? Do you hear me? Testing, testing. Yeah, it looks like you hear me. Very good. And the fifth one, what formula? Let me see. I'm trying to remember. Let me see the test. Okay, so for the last do you want to do it together? You want to do this problem together? Would you like to do that? I think I lost my connection. Hold on. Nope, things are good. Just going to pull up the test and we'll look at it together. All right, it'll feed into what we're doing next anyways. That's not it. Why is this coming up? Go away. I'm a little bit confused. Hold on. I guess it is it. All right. There you go. You don't see that? I have to reconnect. Okay, so remember, if you don't see what I'm talking about or it looks blurry, refresh your screen. I have to do the same thing. There you go. So here's the question. A young couple has made monthly payments of equal size, rounded to the nearest cent, over the past 10 years on a 15-year mortgage of $64,000. The stated annual rate on the mortgage is 5% compounded semi-annually. They are going to renegotiate their mortgage so that they can pay off their loan over the next 10 years at a higher rate of 7% per year compounded semi-annually. The first payment at the new rate will be made at the end of the current month following the renegotiation. What will be the size of the new payment? So it's really important to know what you know and what you don't know. Okay, that's part of critical thinking. Know your limits. So here what we have, I gave you 5 questions to choose from and you only had to do 4 of them, right? You're working on your own at home with all your resources. So I can ask you some probing questions to see if you can see your level of knowledge. As I explained before, this is really a review. This is 3106 that we're doing here. So you should know this, but if you don't, it's okay. We're going to get you up to speed. We're going to get you all on the same page. So what we do when we read any question is we read for the timing of payments. Are there payments? And then what's the timing? What's the situation here? And what's the timing of the payments? Hello, everybody. We have a good group right now. Monthly, okay. So the answer is monthly. So the payments are monthly. Now what? You have to convert all variables to months. Monthly intervals. So what do we have? We have 10 years becomes 10 times 12 or 120 years. No, sorry, 15. Sorry. Well, okay, so let's write this. So you've already paid 10 years or 120 months, but the mortgage is 15 years. Which is a total of 180 months. Okay, what else do we have? I'm just going in order. The stated annual rate on the mortgage is 5%, compounded semi-annually. So this mortgage is a 5% rate compounded semi-annually. What does that mean? So we didn't discuss this, but I did give you all those documents to remind yourself that you should know this. Now, if you don't, you need to learn it now. This is a stated rate. And I'm going to spend some time reviewing this today, okay? And all those documents I gave you with the 2 in front of it, Unit 2, those documents will help you review interest rate conversions, essentially, is what we're going to discuss today. So if you know interest rate conversions, relax. This will just be a review. If you don't, pay close attention to what I'm doing and review this video. So the stated rate is 5% per year, compounded semi-annually. What does that mean? The formulas that I gave you, let me make it clear here. The formulas that I gave you were for effective rates. Any rate that you put in those formulas must be a rate that compounds over the same period that it's stated. In other words, it reflects the compounded effective rate. So here you're given the stated rate. What does that mean? What do I put into the formula when I solve this problem? Oh, let me be even more clear. We need the monthly, because I'm converting everything to months, I need the monthly effective rate. So what is that? What would I fill in here? So how do I know the difference between an effective rate and a stated rate? Here it says per year compounded semi-annually. Those do not match. When they do not match, you have a stated rate. This just reflects simple interest over this period. So a stated rate is just simple interest, which you guys learned about. But what is the effective interest? What do you really pay? What is the compounding rate per month compounded monthly? You see, when these match, that's the effective rate. So this is the compounded, or the this is the effective rate. Effective rate reflecting compound interest per month. Now, are you with me? So what would this be? No one knows. All right. So let's look at what this is. This is the rate per year compounded semi-annually. So let's say this is year 1, 0, and year 1. And that's half a year. So over the year, it's 5% rate. And I told you, because these are different, because the length over what I'm talking about and the compounding interval are different, this just gives me the simple interest. So the simple interest is 5%. But the question is, what is the rate in here? What is the actual rate paid? I'm going to give this a name. So I'm going to present two alternative notations to differentiate between stated and effective. Or let me do this to be clear. Let's write okay. So the notation I'm going to introduce to differentiate all our rates that we're talking about, because some of you are still asking, what about inflation rate? And I mean the real rate and the nominal rate, those are other terms. I'm going to refer to these rates in here. These are the effective. This is really what I want. Let me just use the same color. So there's a rate in here that's effective and a rate in here that's effective. But you've only been told about the simple interest of 5%. So EPR stands for the effective periodic rate. And I put a subscript here because there's different effective periodic rates. I can have an effective monthly rate. Sorry. I have to be clear. I need the effective monthly rate. But what is this? I put a half here. I keep on repeating that I need the effective monthly rate, and then I wrote this. What is this? So I want the effective monthly rate for my calculations, but the closest I can get is this. What is this? It's not, let me write like this. The rate I have to write like this. All right, so all I have here in this drawing is the rate per semi-annual period compounded semi-annually. Again, I'm matching, when I say this, I'm matching those two terms. This is also called the effective semi-annual rate. How do I find it from what I have here? And how do I relate it to what I need? I really want the effective monthly rate. So what I'm going to do, because you guys are pretty quiet and maybe confused, I am going to come back to this after I do the lesson. Okay, so we're going to finish with this problem. Okay, so we're going to say to be continued. To be continued. And I want to get to the lesson and then we'll come back. Okay? So I want you to pull out, for now. So I'm going to stop here. I'm going to come back to this after we conduct the lesson. I need to teach you about interest rate conversions for you to solve this problem, unless you figured it out on your own. So I'm going to go back to this here for the lesson. This is document 2.1, and you should have it either I emailed it to you, or for the other group, if you're watching, it's on your Moodle page. You should be able to get it. Let me know if you cannot find it. This is document 2.1, and we're going to refer to the other documents as well. Okay, so some people know what's going on with the conversions, which is good. Ready? So what we have here is an example of what you would see if you have a credit card. This is what you'd see on your credit card statement every month, either electronically or they mail it to you. It will indicate something like this. It'll tell you what you were charged in interest. It will tell you, it tells you a lot of things, but at least these things. It will tell you the annual interest rate that will be charged, and it's known as APR, and I'll talk about that. So this is annual periodic rate. Annual periodic rate. And then it also tells you this. Daily interest rate next period. So, like any other question, facing this, confronting this, you have to ask yourself the timing of payments. Are there payments here? You make payments on a credit card every month if you have a balance, right? You can pay off the balance completely, or you can pay the minimum payment. It is not advisable just to pay the minimum payment because you will never pay off your card. Even though it seems like you will and you're told that you will, credit card companies and financial institutions have certain privileges about how they can inform you of your debt. And the privileges I'm implying favors them, not you. So you need to be financially literate enough to read a credit card statement. So step one, what are the timing of payments? Or in this situation, what I want to know is, what is the frequency of compounding? Because I need to match my rate to the frequency of the timing. So what's the frequency of compounding on a credit card? What's the frequency of compounding on a credit card? When do you charge interest? At what interval? Miss Sale says daily. Is that correct? Credit cards, frequency of compounding is okay, daily, I think, how you have to pay every month, right? So you have to pay every month, but how do they compound? You need to match them for the formulas, but what do they in fact do? What do you give? You're given things don't match. You have to match them to use the formulas, okay? So in fact, this is a good point. Payments usually, I mean, you can pay your credit card whenever you want if you have a balance, but you get a bill monthly. So it's like payments would be monthly, it seems. But the frequency of compounding is daily. So you should realize there's a lot of interest on a credit card. In fact, my credit card says APR 18.4%, which is quite high. And then I'm told that the daily interest is this. And that looks small. It looks not so worrisome, right? But let's dig into this. What is the relationship between these two? Can someone tell me? What's the relationship? Yeah, so you have good comments, you have to pay what you can pay a credit card whenever you want, but you get the bills monthly. However, they're compounding your outstanding balance daily. So the question is now, it's okay, I'll leave that comment. So what's the relationship between this APR and this? Okay, let's ask an easier question. Given the notation I just taught you before, if this is the daily interest, how could we express this number? I mean, in the symbols that I showed you, where the symbol was EPR 1/365. That's the symbol for the effective period rate daily. This represents the rate per day compounded daily. So I can call that the effective daily rate. So there's two ways to refer to it, but essentially it's an effective daily rate. Okay. Aha, Sophia wrote something. Very good. Okay. So the next question is, well, the original question was, what is the relationship between these two? This is really what you're being charged every day on your outstanding balance. It seems small, but we know the exponential effect of compounding makes this large over time. Exponentially large. Now, Sophia wrote something. Is Sophia correct? You can check it. Again, if it's blurry, just refresh the screen. Is Sophia correct? Good, you're checking. Good. Okay. So she's correct. So then what in the world is this? And that's where we're headed next. But first, what I want to talk about is what is your actual what is the effective annual rate? Because this says annual here, but what is really your effective annual rate? In other words, find the rate. Now you know why I script write, because it's very noisy when I print. Find the rate per year compounded yearly, annually. So these match. That's effective. Okay, because this statement over the year compounded annually reflects the compounding over the interval stated. So that's an effective rate. So for every dollar invested, not invested in this case, for every dollar outstanding, over the year, every day you're charged 0.050411. Let me make that bigger. Let's do that again. Let's do that again. And I'm going to write. So that implies what the intervals are. So this is 1 day, 2 days, 3 days, up to a year. And in every interval, you are charged APR 1365. So if you have $1 in your balance, what would that as your balance for every dollar in your balance? Let's say it that way. What will be the balance after a year? Okay, Michelle thinks it's 18.4. Which is fine, which is it's not correct, but it's fair. It seems like it should be because that's what's written over here. But what I'm demonstrating is that they're different. This number is only the simple interest. it reflects only the simple interest because, as Sophia pointed out, it takes your rate actually I won't write that. It takes your rate times 365 to get this. That's just simple interest. But it's fair that he would think that, or he wrote that. However, going from here to here is really time value of money problem. The difference, the only difference is that I use this notation for I now. But it's the same thing as before, the same formula as before. So it would be the rate here, or the $1 would accumulate to become, so if it's $1, 1.00050,411 to 365. What is that? So I'm just using my understanding of time value of money. $1 invested, 1 plus the rate. What's the rate? It's this thing here per day for 365 days. So this is going to be 1 year. Very good. So he knows. He knows where I'm going. Okay, so this, if you put this in your calculator, where am I getting this from? This is the percentage. This is the decimal. You have to be careful. Now we're going to get into long decimals you have to be cautious with. Okay, I have 20 people. Someone make the calculation carefully and let me know what it is. And let's see if 3 or 4 people can get the right answer. Right, very good. So you have a number and you got 1.2 201,955,891. So what does that mean? That $1 will grow to this. So what is the interest rate then? Is 20%, a little bit more than 20%. So this has a name. This is known as the effective periodic rate 1. I could write like that, but no one does. But this is, notice that when I write my periodic rates, I always use a fraction of a year, right? Everything is related to a year. I can make that more complex, but I'm not going to. This is a fraction of a year. And because it's the whole year, it's not a fraction, right? This is the effective rate per year compounded annually. Or I should just say it's the rate per year. And because these match, we call it effective. Bear with me, I'm trying to build this case here, what we're doing. Oops. All right, so this also has another name, and the name that we use is more common. We call this the effective annual rate. So there's different ways to say things. You have to get into the vocabulary a little to feel confident, okay? But this is the same. Effective annual rate has the acronym EAR. So you can see in my notes I use EAR. You might see this, which helps you relate back to this, because what I'm going to show you demonstrates how to find what are known as equivalent effective rates, how you convert between the rates. Why would we want to do that? Well, I gave you an example at the beginning of the class that how or why we need effective monthly rates for mortgages. It's because the formulas are intended to be used with effective rates. So you want to be able to do this. So if you're given a rate that's stated over, that's a stated rate, in other words, it's not an effective rate, you need to know how to make the conversion. But as you will see, it might not be that straightforward. In this case, it is. All I have to do, if I'm given this annual periodic rate, all I have to do is divide by 365 to get this one. which I've been given both, but I should know the difference. I need to know which one to pick, which one to use in my calculations if I want to figure out how much interest I will owe if I don't pay off my balance. So, in conclusion on this page here, I have determined that the first rate is not the effective rate, but use it to find the effective daily rate for a credit card. You need to take the rate they give you, the APR, and divide it by, you want to divide it by the number of compounding periods over the year. That will be the standard approach, and what I'm going to talk about next. So that's the rule, okay? Take your APR and divide by the number of compounding intervals. For credit cards, you divide by 365. What do you do for mortgages? Actually, you know what? I'll do that. We'll get to that later. So you just got to start thinking, this is what you do for credit cards. For mortgages, you have to do something similar. Payments are monthly, but you have to look at the kind of rate you've been given. In this case, it just says APR. So it's telling me all I have to do is divide by 365. That's basic. If you're given an APR for a mortgage, all you have to do is divide by 12. If you're given an APR for a bond, you divide by 2. So we're going to talk about that. It depends on the kind of arrangement, okay? So this is how you do credit cards. This is how you handle credit cards. Right. Credit cards. But you have to look at the terms. You have to identify what's your effective rate. And you can basically ignore this, but you should know what it is. APR relates to the effective rate that you're actually paying. So these numbers are different. You really pay 20%, not 18%. And, you know, people can say, oh, it's not a big deal. It's almost 2% off. It's not it's not a big difference. But it's misleading. It is misleading that this is less than this. And when it comes to financial institutions that perform or have contracts in the trillions, I'm talking about totals, the kind of business that they do, this really adds up over time. Daily interest, you can imagine. So they're making much more from you than you might be aware if you just look at the 18%. All right, so pay off your balances. There are benefits to paying off your balances. The greatest benefit is your credit score. Well, I guess the greatest benefit is peace of mind, but your credit score is impacted by not having outstanding balances. All right, so let's see. What do we do next? So all we've learned so far, what we've learned is, well, it's not exactly, the main thing we learned is this notation, really, because we already know this. I just applied it. So let's see. I'm going to summarize my notation, and so what I gave you in this document 2.2 is something to read and the notation, okay? So I actually create an additional notation for this thing. It just helps with my formula. It might help some students. It might not help other students. It might confuse some students, but bear with me. This technique worked for me when I was learning how to conduct interest rate conversions and make sense of all this. The main thing is that we use a different notation. The little r is for stated rates, the EPR is for effective rates. In the formulas I present, I use n for the length of compounding interval and 1 over n for the number of compounding periods. This notation becomes important when, well, you'll see when I make general formula, but don't let it overwhelm you. Stick with this. If we have the rate per year compounded every period n, these don't match, right? Where n is the length of the compounding interval, and like this is the fraction of the year. So when it's a fraction here and it says per year here, this is a stated rate. So I've already said that. So it turns out, just some standard ones, there's the credit card rates that are stated daily rates. So they are 1 over 365. Usually mortgages have a annual rate compounded monthly. So those are R112s. We call those stated monthly rates. The example that we started with today from the exercise question 5 on the test, what kind of rate was that? If you go back, it was actually, what's the 5%? What symbol would this have? It's the rate per year compounded semi-annually. And I even drew it here. So this was not like a usual rate that you would see in the United States. Usually mortgage rates are presented as R112, but this one is R1/2. And that is the case. Different countries have different conventions. And in some countries, if you have a mortgage in another country, you have to be careful that you read it properly. This is a R1/2, not an R112. Okay? I see your comments, don't worry. Okay. All right, so what else do we have? So just to recap what I'm doing, I'm just introducing this notation R for stated rates. And the first one that we saw was in the, the one that we saw on this page is daily stated rate. Mortgage rates in the US are in R112. But other countries might have R1/2. For dividends, be careful if you are solving problems or you're reading about stated rates for stockholders. Those are R1/4 because stockholders are paid quarterly. Or if they are paid dividends, they're paid quarterly. So that's R112. When you deal with bonds, bonds are paid coupons. We talked about coupon bonds. And the examples I gave you, I was always talking about annual coupons. Well, in fact, the convention is to pay bonds semi-annually. So when you read about the rate, it's a semi-annual rate. Okay, so these are the conventions. And sometimes when you read problems or you read literature, it's assumed that you know the frequency of payment, or the frequency of, not payment, but compounding. Okay, so compounding varies given the application. So those are stated rates. Then I already mentioned the effective rates to you for the credit card. To make calculations, you need the effective daily rate. For mortgages, you need the effective monthly rate. To solve problems where compounding is quarterly, you need the effective quarterly rate. And for bond problems, you're going to need the effective semi-annual rate. And I've also expressed here alternate ways to see this. So this is the symbol, this is what we say, and this is what it means. The daily rate compounded daily, the monthly rate. Notice all the way down, these match, so that tells you it's effective. So, what is the relationship between effective rates and stated rates? Which is the essence of what we discussed with this handout. This is the calculation that Sophia mentioned we should make. In general, you can get the effective rate by just dividing by the number of compounding periods in a year. So for credit cards, take that APR and divide by 365. For mortgages, take that APR and divide by 12. Okay. what else did we talk about? For bonds, take the APR and divide by 2. So what am I dividing by every time? The subscript tells me. Oh, I wrote this wrong. Those are subscripts. It looks funny because they made it the same size. Let me do that again. That's a subscript. Now some students get confused because I have it in the denominator, but I also have it as a subscript. Don't let it confuse you. That's all I can ask. And don't get confused by the fact that I'm using n and then these are fractions, right? It's the fraction of the n is the fraction of a year. Everything is related to years. So that's converting from stated rates to effective rates. You good so far? So you should have learned this. But again, if you haven't, it's fine because we're doing it now. So what about converting in between effective rates? That's the second skill set. And I summarize that here on this thing I call interest rate conversions, solutions, problems and solutions. So I just presented to you converting between effective rates and stated rates. But what if you want to convert between effective rates? What am I talking about? This is important when you're given information up here about the stated rate. And you can make a direct conversion to the effective rate. However, it might not be the effective rate you need. What is the effective rate you need? You need the rate that compounds at this in the same, that is stated and compounds in the same interval as your payments in a payment problem. So you will need to make this conversion. Now what is going on here? In the problem that we did, I'm going to pull away from here. This helps. This is what we did already. I'm going to take a portion of this set of equivalencies. They're all equal, so I can relate 365 days compounding of 365 daily accumulation factors to make a year, right? I can that's what I did here. I did 1 plus, let me put it down. You see what I did? For every dollar invested, you always imagine there's a 1 there. I did 1 plus the effective daily rate to the factor of 365. I accumulated 365 just using the basic time value of money to get 1 plus EAR. That's what this is. Okay? And then when I get my calculation, it's 1 plus So this piece is my effective annual rate. That's what I did here. I pulled it out. So this is the effective annual rate. So that's just one example. We've already covered this. This is summarizing, in fact. Okay, so Michelle asked the question, will the effective rate always be greater than the stated rate? The effective rate will always be greater than the stated rate when we use fractions of a year that are less than 1. Now, in fact, we can use, it could be the case that we use compounding frequencies that are greater than 1. But I don't get into that too much. You need to know that by the time you write the CFA exam. And I do have a few examples. I think I give you a few examples. It's not a stretch. If you get really good at this, you can do the other calculations as well. Okay? It's really important to understand essentially what we're doing here, so then you can apply it in any case. But on most of my problems, I give you compounding frequency that is less than 1. So yes, the effective rate over the same period converts into a rate that's greater than the stated rate. Okay, so back to my summary. This is like my summary here. So what we see is 365 accumulated days is 1 year. 12 accumulation factors of the monthly rate is a year. 4 quarters is a year, and 2 halves is a year. And one quick check to feel, comfortable with what you're doing. If you multiply this fraction by 365, this is the exponent though, they're not being multiplied, but I'm saying if you look at this, you get 1, right? You're accumulating, you're compounding as many as there are fractions of a year in a year. Fractions of a year, there's 12 in a year, and you're accumulating over them. Here there's 4 quarters, 4 factors makes 1 year, and 2 halves make a year. And now the beauty of this expression is that it shows me, it demonstrates that I can also go in between any of these. If I have the monthly effective rate given to me, I can get the quarterly effective rate with this relationship. Anyway, we'll see examples like that. So I just solved some problems here. These are just the ones that we already did. I show here how to get your effective rate from your stated rate. And I show how to get to the annual effective rate from the daily rate. So I've used both formulas. So you need to be clear what you're doing. Do not just make calculations blindly. Really understand what this is saying. It'll make everything easier if you understand. So this is effective rates and stated rates, conversions. And this is effective rate to a different effective rate. And that's the way it's done. All right. What do I have next? Some exercises, I believe. Here we go. So with these exercises, I've given you all the solutions. So let's just get into this. So let's look at question 1. So it's 11 o'clock. I should go an extra half hour today. And just like last time, you guys can leave if you have to, and then just watch the end of the video when you get the chance. All right, so pull up this document 2.4. Hello?
Hello, Professor. I'm sorry I'm calling you. I'm Misael from FINA 41.
You can't hear me? Nobody said anything. I guess there's some delay. Okay, so let me repeat from the beginning. I don't know what happened. 10 minutes. Oh my goodness. So, did you miss all of this page? Did you follow? Did you get this page? Okay. Okay. No, sorry. I must have tapped that at some point. Okay, let me clear. Let me clear and speak again. Okay, consider a bond paying semi-annual coupons. At a rate of 12%. So what is this rate? We have a face value of 1,000, maturing in 25 years, and we have the price. The bond is paying coupons semi-annually. Now, until this point, the coupons were annual. Okay, I never mentioned semi-annual or different rate, but in fact, it is the convention for coupons to be paid semi-annually. So we need to deal with this problem. This rate is stated because it tells you it's an annual rate even though they are semi-annual. So this is the kind of confusion. If you don't know what's going on, this can create confusion in your calculations. So what you in fact have is a stated rate. And the symbol for a stated rate, I always say R1/2. Now you have the impression that I use R just for interest rates, but the interest rate is this one that I'm trying to find. This is just the coupon rate. But I'm writing this way to remind you of something. I'm trying to remind you that you have to do something to get the effective semi-annual rate. Okay? So to avoid confusing you, because these are the symbols for interest rates, I make this statement down here. Remember, to get the payment, it's C times FV, right? But before I can make that calculation, I have to divide by 2. So that's what I do. So now that we're doing the more realistic problems, always remember, take your coupon rate, divide by 2 before you multiply it by FV to get the dollar periodic rate. If you want to do it the other way around, if you have the dollar periodic coupon payment, and you need the coupon rate, you have to do the reverse calculation. This is just algebra. Okay. I make it curvy just because to remind you it's the small one, it's the rate. And the big capital C represents the dollars. So depending what you want, in this problem, we need the, we want to find the interest rate. So let me pull this problem so you guys can review that. I'm going to pull this problem with me and we'll solve it. On a blank page. So what is the formula for a coupon bond? The price is equal to the annuity piece, right, with the payments, so that's the general formula. Now we have to adapt this. The first step, payments are semi-annual. Convert all rates to semi-annual periods. Sorry, not all rates, all variables. Let me see if I can make that neater. Convert all variables to semi-annual periods. So the first one is the coupon rate is should be divided by 2. I'll just jump into it. And multiplied by FV to get the payment. So that's going to be 0.12 divided by 2 times 1,000 gives me $60. Next, 25 years should be 25 times 2, 50 semi-annual periods. What else? The rate we want to find and we have the price. Do we have everything we need? We have the C1 is the payment. I is what we want to solve. We have this. We know FV is always 1,000. That doesn't change. And we have price. So we have everything so we can solve for the yield to maturity. Keep in mind what we'll get out of here What will it be called? If all your variables are semi-annual and you use your calculator, you will get the effective semi-annual rate. But notice what you're being asked to find. You're being asked to find the rate per year compounded semi-annually. So what are we finding? So solve this problem. We're going to set up the formula. We're going to solve this in our calculator. And the last step will be to convert it to the stated rate, because bonds have stated rates, stated yield to maturity, YTM. So let's put everything in to the formula. So for the test purpose, I'm going to use 1,057.98 is equal to $60. This one I don't know, leave it like that. 50 periods, and then 1,000 and 1 plus I. And what you will get is the effective semi-annual rate. Now you'll see in some of my notes I actually put that in there. They're the same thing. So let's go to the calculator. Ready? All right. So we begin. You can clear TVM if you're worried that there's some stray number in there. But as long as we hit all the keys, we override anything that was in there previously. So N is 50. The rate is what we want. PV is 10, 57. What were the decimals? Let's go back. 98. Now I'm going to enter that as a cash outflow as a prospective investor. That's what I would spend. And then I will get $60 and $1,000. So I can ask to compute the rate. There we go. So 5.649995. All right, so follow the instructions provided in any test situation. So sometimes I'll say just write down 4 decimal places. Let's do more. Let's do 6 for this because this is an intermediate calculation. It's not the final. So 5.64 with 3 nines. 5. So that's my rate as an effective rate one minute. So what I need is the stated rate. So usually what we were doing is dividing stated by the number of periods in a year. But I have to do the reverse. You do the opposite. Because I have the rate already, as stated, I want to convert it. So this is basically, in other words, you just want to give them the simple interest rate. That's just a multiplicative thing. So you just multiply. So what I'm going to do is store this in 1 and multiply by 2. So it's 11.2 and 4 nines. If I want 6 decimal places, I have to put a 0, but you know. Are we good? Did we do it right? 649,995. Let's see. Let me see my clave. I sent you the clave. And that's this one. Okay. Just one moment. I'm going to turn my volume off. All right. Just review it. I'm going to take a 5-minute break. You guys can try the next one. To review and try the next problem. Diego asks, what is R1/2? It's the simple interest. The yield to maturity for bonds is a stated rate. I wrote 5-minute break, Diego. Five minutes to review and try question 2. Okay, how'd you do? Questions? No questions? Okay, let's do the second one. Second problem. Consider a bond paying semi-annual coupons at an annual rate of 7% with a face value of 1,000, the price, and you have the YTM, and they're asking you for the time. All right, let's see. Same formula. With the coupon payments as an annuity and the time value of money formula for the face value. This is the basic TVM. Right, so what do we have everything. We're just going to have T missing, right? T is what we need. So again, semi-annual coupons at a rate of 7%. These are different. So we need to make that conversion So we need first the payment, which is going to be the rate divided by 2 times FV, right? That's the way we do things now, because we learned that coupon bonds are paid coupons semi-annually. That's $35. So those are the semi-annual coupons. And then what do we have? Do we have everything else? We need to convert. Notice that needs to be converted too. So let's just make a note here. Convert all variables. Convert all variables to semi-annual periods. And I'm just going to put I again. No, I can actually calculate it, right? I'm missing that variable. Let's do that. So the other variable is, let me erase this. The other thing we have to do is convert this is the stated semi-annual rate So I need the effective semi-annual rate, which is the stated one, divided by 2, or 0.066 divided by 2, which is 0.033. Okay, now we're ready. Remember, face value is always 1,000. It doesn't say it there, you should know it. All right. So that's the formula with all the values entered. And now we ask for years. But in this case, what are years? What are periods? It's semi-annual periods. T is in semi-annual periods. So let's enter this into the calculator then. So let's clear TVM. And I don't know, it's what I want to find out. So I have to put in 3.3 as my rate. And then, now I have to go back again and see that. It's 1026.82. 1026.82 is going to be a negative for the present value because prospective investors would spend that, and then they get $35 and 1,000. So easy when you do bonds. You know what you're doing. Now we ask for time. How's that? Questions? Right, so it's like almost 18, but I can't round it because it's not the last step. So 17.9980647. $8,064. Semi-annual periods, right? These are semi-annual periods. The question, though, is how many years? You have to do the opposite. To get semi-annual periods, we multiplied. So to get back to years, we have to, do that again. You have to divide. Good. 9. You got 9? So you can just round it because it's the final answer. It's going to be 9 years. Oops. All right. So good. Yes, nice, Beth. Right, so always remember we need to solve problems in the timing of payments and then make adjustments. That is your anchor. That is your approach, okay? That's your method. Questions? Are we good? All right, so you need to read. If it doesn't tell you something, then you assume it's like a bond where everything is a stated rate. But you see, this is how you know. Per year, compounded semi-annually, this is R 1/2. Because, no parin. This is a year and this is semi-annual. So it's stated over the year, but it compounds semi-annual. It's a stated rate. Si no dice nada, if it doesn't say anything, assume it's this. Okay, that's what you have to do from now on. You need to know the certain application for mortgages, coupon bonds, dividends. Okay. Let's see the next problem. What's the next problem? Okay, mortgages. So I give you some discussion here about mortgages and I start solving. So, what is the monthly payment on the mortgage above? So a mortgage is a loan that is repaid in monthly installments. You could pay more than every month, but it's at the minimum, well, unless you want a penalty, you have to pay monthly payments. Okay, so it's arranged as an amortized loan with monthly payments, and interest continues to accumulate on the outstanding balance. So let's see, let's drag out the info. So these are the details. And you want to get the monthly payment. So you want to know the payment on this annuity. So the formula we're going to use is this one. So we need to know the payment. That's what we want to find. We need the right interest rate. And we need the periods. So payments are monthly. Convert the variables to months. So the rate you've been given is 7.4 per year compounded monthly. So what is that? It's an R112. Okay, so I know it because it's stated over the year, but it's monthly compounding, and I denote that with a subscript 112. But we need the effective monthly rate. To get it, we take the stated rate and divide by 12. That's the rule, right? Stated rate, you can write it like this. You could write it as a percent to get the rate. Very good. So this is 0.00616 repeating. So this is, I'm going to store this because this is going to get messy. I can't write that out every time, and I don't want to lose any of the decimal places because think about it. 25 years of monthly payments. That's a lot of payments. How many payments is that? $25 times 12, right? Those decimals are going to matter. What else do we need to convert? So we've done I, T, and we need to find this, and we have this, right? Because this is what we're borrowing. So this is going to be a positive cash flow. These will be negative, and we have what we need. So I'm going to take this number and store it for my calculations. Be careful because let me tell you something. Let me multiply that by 100 first. Either you multiply it by 100 or you use the percentage here. The point is, this is what you store because you need the percentage value. All right, so let's put the formula together. It's going to be $100,000. And then C1 is what I want. And this is messy to write, so I'll just write EPR 1 over 12, or just I. And so all I have to do is write that and then solve for C1 in my calculator. So let's do this together. Clear my TVM. So N is 300. Interest I got from 7.4 divided by 12. And I can put that right into here. Or I could have put 0.074 divided by 12, and then I have to times by 100, and then store 1, and then recall to put it there. But I was able to do it all in one shot. Okay, so 7.4 divided by 12, and that's basically what I want in here. The PV, the price, is $100,000 loan that I get, so that will be entered as a positive. And for a loan, this is not a bond. For a loan, a mortgage, it's just an annuity. So I'm going to override what's an FV, and I'm going to compute the payment. So payments are made in dollars and cents. And this one will round to $732.50. So that's what's going to go. That's going to be the mortgage payment. All right, so that's another tip that you know that since mortgage payments are in dollars and cents, the payment is $732.50. So remember that if you use something like Excel for an amortization, you have to be careful that you keep it in dollars and cents. Don't keep all the decimal places, because people don't pay in decimal places. They'll pay in dollars and cents. All right, so it's 11:50. I said I would go over what I'm going to do instead is let you go, and what I will post is a video solution of the problem we started with, okay? And you guys can watch it. I will send a link to it by email once I've done it, and that's what we'll do. It's just that I have to have a meeting with students from my other class, and that will be at 1, and I need to notify them right away and prepare for that meeting. So finish reading this and try these problems ahead. You have all the answers, so work through these documents. Let's see, let me tell you which ones to work through, how far you can get. I mean, you could get through all of them, really, but let's see if I give you a realistic goal. Okay, so you have, so this is the solution. Okay, you have the solutions for that, 2.5. Then you have problems. Okay, so you have 2.6, 2.8, and then 2.10, 2.11. Let me see where I can get us to. So over the week, what I want you to do is prepare studying all of these documents. It goes to 214, and 214 is solving for G. Okay. So work on all of them. Next week, okay, let me just make a note. So review I'll post a video solution to the test question 5. You should review all the notes to 2.14, and then next class I'll answer your questions. And present some challenging problems. So again, I want to start Unit 3. So I don't want to spend the whole class on that. I want to start Unit 3. So you are going to have to conduct your review of all the Unit 2 notes, and then come to me next week with problems. You have all the solutions, and I will present some new challenging questions. I'll give you like 2, and let's see. I'll assess how good you guys are, how well you're doing, okay? Like I say, I don't want to spend the whole class on that because you do have the solutions, but where you're confused, we can go over it. I also gave you what I gave you in there I believe is a summary. Did I give you a summary? Yes. So 213 is a summary of how you should solve these problems step by step. It's very general, of course. Timing of payments and convert all to the same interval. Step 2, draw your timelines and solve the problem where they fall on the timeline, but then modify or shift all your lump sum amounts to evaluate the asset either at the present or at some other time. So this is solving valuation problems, right? So stocks, bonds, mortgages, investments, all of that. The next unit is going to be using all these techniques to make alternative or to choose between alternative investment opportunities. So you should already know how to value assets, and I'm going to teach you about how to make decisions among investments that we can also evaluate as though they are an asset. Okay, so that's going to be something new. But all of this for me, honestly, is a review, and you're going to have to tell me if you need any additional help. I can meet with you in office hours during the week, so let me know. That would be great if you let me know, and we post the videos for people to review. Okay, so other than that, I'm going to let you go with 5 minutes to spare. Okay, so goodbye for now.